I hope everyone is doing great. Yeah, you must be wondering that why sir is wearing a shirt today, right? Actually, I just, it's been a long story about this shirt. I just bought it, a week ago, and I thought, now we are not going outside. It's, Corona time is going on, so why not to wear it, right? While collecting a glass, right? Okay, so guys, yeah, let's come back to the thing. So in today's session we are doing real numbers, right? And it's been the fourth lecture of real numbers. And in today's class we are going to learn about irrationality of numbers, and how to convert from decimal to form to the fractional form, and these kind of things of irrational numbers, right? At the same time we are going to learn that how to prove that a given number is an irrational number, right? Okay, for example, let's say if I say root of 3 is an irrational number. How do you know that? Can you prove that is root 3 is irrational? Because look, to get to say that it's an irrational number, you cannot represent it in the form of p by q, right? Okay. Now you don't know the decimal expansion of root 3, and you're not sure how you're gonna find that. So how you gonna say it is irrational or rational? That's quite a challenging thing right now. Okay. So answer of that challenge we are going to do right now in today's session. And one more thing, guys, this is gonna be something I would say a bit difficult for people, because I have been seeing the students facing issues in this particular part. Okay, so pay more attention to it in today's session. Okay, and definitely we'll learn whatever is there, right? Okay, so let me start sharing my screen and let's do this. Yeah, guys, so my screen is visible, I hope, right? Yeah, fine. So we are going to do today proving irrationality of numbers and the decimal expansion of irrational and rational numbers, right? We have been already learning that what is a real number, and we have seen that in the real number, under the category of real number, rational comes, and under rational there are integers, there are fractions, there are whole numbers, there are natural numbers. Okay, and irrational also we have been seen that, okay, pi is an irrational number, e is an irrational number, e is Euler's constant, right? Its value is almost 2.71, but not exactly 2.71 because it is irrational, right? And then root 2 is also an irrational number. And why root 2 is an irrational number? That is what something we are going to prove today. Okay, we have been knowing that, yeah, it is irrational, but why? So the answer of that why you will get just after 5 minutes. Okay, let's start. So guys, how to prove that? Actually, first of all, we need to understand the method, that how we're gonna prove the irrationality of the given numbers. Okay, so look, let's read the first line. It's very important. The irrational numbers are the real numbers which cannot be, which are not rational. What it says that. So basically, they are number which cannot be represented in the form of p by q, because a rational number is something which can be represented in the form of p by q, right? So when I'm saying that it's an irrational number, that means you cannot represent that number in the form of p by q. That is clear to us, right, everyone? Now just let's try to understand what we are going to do actually over here, right? So we will be whatever number will be giving to you, and they will be saying, okay, prove that this number is irrational. For example, prove that under root of 2 is irrational. Okay, first of all, we'll let that it is not irrational, we'll let that it is rational. Okay, or we'll say that root 2 is equals to some a upon some b. Okay, when a and b are co-prime numbers, right? Okay, because we can represent a rational number in the p by q form where p and q are co-prime, right? So we'll let that, okay, root 2 equals to a upon b where a and b are co-prime, and then after that we'll be solving it and we'll be proving that whatever we have been assuming, root 2 equals to a by b, that's not possible. Okay, right? Contradiction, we call it contradiction method. We assume something to be true, and then at the end we prove that whatever we have been assuming was not correct, and then we say that by the contradictory method, that is contradiction to us, that's not a true statement, that's a false statement. So whatever we have been assuming isn't true. Okay, abhi samajh mein aayega, don't worry about that. Okay, there was just a process to explain you. Look at this now. This is a video. If you want, you can see this video after the class. Okay, but right now I'll just move forward and I'll just show you how to do it. Okay, so look, the theorem is that if p is a prime number, then under root of p is irrational. Now this is very, very, very important, right? So for any prime number, its square root is gonna be irrational. So like the square root of 2 is irrational, square root of 3 irrational, 5, 6, 11, 7, under root of 7, under root of 11, right? They all of them are irrational. Okay, but don't assume that ना कभी कभी कुछ लोग बोलते हैं अच्छा सर, okay, that means the vice versa is also true ना. That means if if p is a irrational number, okay, sorry, if root of p is a irrational number, then p is definitely a prime number. That's not true. Because look, let's say if a number is 6, okay, square root would be what? Root of 6. It's not rational. It is also irrational. This is also irrational, right? Okay, so vice versa is not true. But yeah, if you have a prime number, if you take the square root of that prime number, whatever you will get is irrational. But whatever you are getting, they are not the only irrational number. There can be more irrational number. For an example, as I told you, square root of 6, right? So square root of 6 is an irrational number, though 6 is not prime. Okay, so what is the meaning of that? That for prime number, it's always true. But for the other number, it can also be true. Okay, but right now we are talking about the prime numbers, right? Let's see how we prove this thing. It's very simple. Look at this. So we just said that root p is irrational. Okay, so first of all, as I told you, we'll always let that it is rational. So we have let that root p is rational. If it is rational, it can be represented in the form of a by b, where a and b are co-prime. Okay, we did the square. We got p equals to a square by b square. Fine. I can write a square equals to p times of b square. Now pay attention on this thing, guys. Can I say that p is dividing a square? You remember that one? Dividend equals to divisor into quotient plus remainder. Just assume that right now the dividend is a square. The quotient is b square. The divisor is p, and the remainder is 0. So a square equals to p times b square plus 0, right? Okay. So by that we can say that p is dividing a square. P divides a square, right? Now a is a prime number because we know now a and b are co-prime when we are writing p equals to a by b. Okay. So it's a prime number. Think about that now. That if a, what is a square? A square is a into a, right? Product of two primes. It is product of two primes, right? If it is product of two primes and p is dividing a square, that means p will divide a as well, right? For an example, what I'm trying to say is to that, just read the statement. When a prime number divides the product of two number, it divides one of them. Listen, for an example बता दूं आपको, कोई भी एक नंबर ले लो. Okay, 5 into 7, 35. Up there is a prime number, there's a number, prime number rather I would say, which divides 35. So let's say the prime number is 5. So 5 divides 35 and 7 divides 35. There's only two numbers which divides it, right? So 35 is 5 into 7. So 5 is dividing because 5 is dividing one of the factors. 7 divides because 7 is dividing one of the factors, right? Okay, so basically what happens is that आप ऐसे समझ लो इसको directly, that if there's a prime number p which is dividing a square, it will also divides a. Simple. Okay, so hence p will divide a. अब एक बात सोचो आप, अगर if p is dividing a, that means if I multiply p by an integer, what I'll get would be a, right? That means a is p times of some integer. So what we wrote is that a is p times of k over here, right? Now we know that what was a. If I, okay, first of all let's do a square. यहाँ पे statement यहाँ पे लिखता हूँ मैं आप लोगों के लिए. So a square would be p k whole square. Now look at this. A square was already what? Pb square na from here. Look at this. Okay, so I'll put it over here. So I'll get p square k square, right? Okay, a square was p times of b square, right? From here we get that b square equals to p times of k square. That means now b will divide, p will divide, sorry. Now p will divide b square as well. So again, by the same thing that what we have done earlier, we can say that p divides b as well, right? Okay, that means p divide kar raha hai a ko b and p is dividing b as well. Just think about it now. P was a number, root p was a number, a by b. Okay, a is sometimes of p and b is also sometimes of p because a and b both have a common factor p. P is dividing a as well and p is dividing b as well. But wait, that's not possible, right? Because what we have said in the beginning that a and b, they has to be co-prime, right? But right now after solving what we have got that a has a factor p and b also have a factor p. A and B, both of them have a factor and that is B, but that's not possible. They have to be co-prime. They are not co-prime. What is the meaning of that? That means whatever you have been assuming, it's not true. You have assumed that root P equals to A by B. That's not true, man. That's wrong. That's absolutely wrong. The assumption is wrong. Why? Why our assumption is wrong? That because we have just proved that A has a factor of P, B also has a factor of P, or rather I can say that P divides A and B, both of the numbers, right? So P and That means P is a common factor of A and B. That means they are not co-prime. They have to be co-prime, but right? Okay. So by the method of contradiction, we can say that whatever we have been assuming was not correct. So we have been assuming that root P is a rational number. So that means that's not correct. So if it is not rational, it is what? Only two kind of number exist now. Either it's rational, it's not rational, it's irrational basically. So it is not rational. That means it is irrational. So what we have proved now that if P is a just a second yeah screen पे कुछ आ गया हाँ if P is a prime number then square root of P would be a irrational number, right? So अभी क्या होता है when someone is asking you that okay is root 2 a rational numbers or irrational number, you'll say it's irrational, right? Because 2 is a prime number, its square root is gonna be irrational, right? Okay, what about root 3? Is it irrational or rational? You will again say it's not a rational number, it's irrational number, right? And I hope you got the concept over here. Let's move forward. This is the first theorem that's very, very important for you guys. Okay. So please keep this thing in your mind and note down the proof as well. Okay. So question करते हैं अभी यहाँ पे. Question ये है कि given that root 2 is irrational, it is given to you that root 2 is irrational. You have to prove that 5 plus 3 root 2 is also irrational, right? So as I told you, first of all, what you will do, oh, sorry, you will assume that 5 plus root 5 plus 3 root 2 is a by b. You have assumed that it is rational. Let 5 plus 3 root 2 is rational, and if you are writing it as a by b, that means here a and b are co-prime numbers, right? Abhi, you solve it yourself. I'm giving you 2 minutes. Take your time. Ultimately, you have to prove that whatever you have been assuming was not correct. Give it a try. Exactly 2 minutes, and I'll start the discussion. Okay. All right. चलो let me discuss now. ठीक है, देखो अभी कैसे करना है. So एक काम कर सकते हो आप लोग कैसे कर रहे हो पहले बताओ. देखो दो चीज हो सकती है, या तो आप इसका भी स्क्वायर कर दो both sides, but that's gonna be a bit lengthier, right? So what you will do rather than, you will write that 3 root 2 equals to a by b minus 5 and yet then you do the square. This is one of the method, right? Okay, so next slide करते हैं, I'll explain it there, right? देखो, so यहाँ पे आ चुके हैं हम लोग. That 3 root 2 equals to a by b minus 5. Then what I said that square कर दो. Square नहीं भी करना है तो एक काम और कर सकते हो कि सारा सारा कुछ पहले उधर ले जाओ, ये ज्यादा सिंपल रहेगा आपके लिए, ठीक है? So divide by 3 कर दिया तो क्या आ गया, root 2 equals to a minus 5b over 3b. अब it is given to you in the question that root 2 is irrational. ये given है ऑलरेडी क्वेश्चन के अंदर, root 2 क्या है, irrational नंबर है, ठीक है? अब देखो, अब समझना बात को. A क्या है, A is an integer, B is also an integer and they are co-prime as well. तो a minus 5b is also an integer and divided by 3b is also integer divided by integer. तो ये जो नंबर लिखा हुआ है ये किस तरह का नंबर है, ये तो रैशनल नंबर हो गया, ये तो रैशनल है. बट रूट 2 इज व्हाट, इररेशनल. ओ माय गॉड, व्हाट इज दैट? आप बोल रहे हो कि आप बोल रहे हो कि गधे गधे और घोड़े बराबर हो रहे हैं. आप बोल रहे हो कि वन डोंकी इज इक्वल टू वन मंकी. ऐसे बोल दो आप ना, गधे और घोड़े मत करो, आप तो बोलो गधे और बंदर. Donkeys and monkeys are equal. Oh, come on, man. That's not possible. That's not possible, right? So फिर ये possible नहीं है तो ये क्यों possible है? Right? This is also not possible. An irrational number cannot be equal to a rational number. That's impossible, right? Okay. So अब देखो, that means क्या हुआ? Whatever you have been assuming is not true. Because आपका assumption wrong था, तभी तो आपका statement गलत हो गया at the end. You have proved true. You have just said that rational and irrational are equal. That's not possible, right? So assumption has not to be true. And that means whatever you have been assuming is not correct. So what you have assuming in the beginning, you have assumed that 5 plus root 3 root 2 is rational. That means it is not rational, it is irrational. Got it? Simple method hota hai yaar, it's not very difficult thing. Okay, fine. Chalo, let's move. So decimal expansion of rational and irrational numbers, guys. Okay, so देखो अब ना decimal expansion की जब आप बात कर रहे हो, whether talking about irrational or rational, so फर्स्ट ऑफ ऑल तो डेसिमल एक्सपेंशन कितने टाइप होता है डेसिमल एक्सपेंशन के, वी नीड टू अंडरस्टैंड दैट, राइट? देखो दो तरह के होते हैं, एक होता है टर्मिनेटिंग, यहाँ पे लिखा हुआ देखो, टर्मिनेटिंग डेसिमल एक्सपेंशन एंड नॉन टर्मिनेटिंग डेसिमल एक्सपेंशन. नॉन टर्मिनेटिंग इज ऑल्सो ऑफ टू टाइप. कैसे होता है नॉन टर्मिनेटिंग के अंदर? आई एक्सप्लेन टू यू, डोंट वरी. एक होता है रिकरिंग, एक होता है नॉन रिकरिंग. वन इज कॉल्ड रिकरिंग एंड वन इज कॉल्ड नॉन रिकरिंग. फर्स्ट ऑफ ऑल, व्हाट इज रिकरिंग? रिकरिंग मीन्स जो रीअकर हो रहा है. रिकरिंग मीन्स रीअकरिंग. ओके, दैट मीन इट इज रिपीटिंग. दैट मीन्स 1.314 314 314, it is repeating, right? It's recurring, it's repeating its things again, right? Non recurring means it's not repeating. That means ऐसा कुछ भी लिख लो आप, 1.217345678912125623894. There is no pattern, right? There is no pattern at all. And if there is no pattern at all, that means we'll say it is non-recurring. It's going on like that, but it's not recurring. It's not having any pattern. It's not repeating. And it's not terminating as well. It's not ending. It's going on like that. आप डिवाइड करते जाओ, ऐसे आता आगे आता जाएगा. It will never end. Okay, so these things are called the non-recurring one. अब देखो यहाँ पे important, what is the important thing, that जो irrational numbers होते हैं ना, whatever the irrational numbers are there, for their decimal expansion what we got is non-terminating and non-recurring. Non-terminating and non-recurring is for irrational numbers. So decimal expansion of an irrational number is, it is non-terminating and non-recurring kind of decimal expansion, right? Decimal expansion of irrational numbers are what kind of decimal expansions? They are non-terminating and non-recurring. Fine. So terminating definitely क्या है? Rational है. And non-terminating और repeating भी क्या है? Rational है. Irrational कौन सा है फिर? Irrational is non-terminating as well as non-recurring. Okay, got it? चलो, अब यहाँ पे दो बहुत इंपॉर्टेंट थ्योरम है. देखो क्या होता है कि एक तो तरीका ये है कि आप नंबर को सॉल्व करो, देन यू गेट टू नो कि वो रिकरिंग है, वो नॉन रिकरिंग है, वो टर्मिनेटिंग है या नॉन टर्मिनेटिंग. जैसे अब मैं आपको बोलता हूँ कि चलो बताओ, राइट नाउ व्हाट आइडिया यू हैव इज दैट √2, ओके, 1 by let's say 21 and 1 by let's say 256, राइट? ओके, सो इफ आई आस्क यू राइट नाउ कि इन तीनों के डेसिमल एक्सपेंशन के बारे में कमेंट करो, कमेंट अबाउट द डेसिमल एक्सपेंशन ऑफ दीस थ्री थिंग्स. सो व्हाट यू आर गोइंग टू से, you are sure about one thing, that okay, √2 is a irrational number, right? So irrational number का decimal expansion would be what kind of decimal expansion? It's gonna be non-terminating and non-repeating. Okay, so you are quite sure about √2. You will say, sir, it is non-repeating first of all, as well as it is non-terminating as well, right? It is non-repeating and non-terminating. That we are quite sure about. But if I say what about 1 by 21 and 1 by 256, you are not sure about it, right? Okay, it is either the terminating ones, or it is, if it is not terminating, it is recurring ones, because both of them are rational numbers. We have just learned that for rational number there are two kind of possible. One kind is that they are ending, they are terminating. Second, they are not terminating but they are repeating. Right now in this one, we cannot say, it can be anything out of those two, right? So without even solving it, how can we say that? So that's why we are going to discuss these two given theorems, right? Okay, so what the theorem says is that first of all, so whatever number is given to you, you will solve it in a manner that the numerator and denominator, they are co-prime numbers, right? So what it says that if any number you are representing in the form of p by q, it's a rational number, okay, and it should be such that p and q are co-prime. अब अगर जो q है आपका, if q is the only factor of 2 and 5, if q is the factor of 2 and 5 only, then it will terminate. If it is other than 2 and 5, it is a factor of something else, it will not terminate. I'll give an example. 1 by 21 is what? 3 into 7. Okay, And 1 by 256 is what? 1 by 256 would be 2 power what? 8, right? Right now, up 2 power 8 के अंदर you can see the denominator is only have the factors of 2. Okay, so when it has only factors of either 2 or 5, it will terminate. So ये क्या है? This is terminating. This is terminating. Fine. But 1 by this 3 into 7, this is non-terminating. Why it is non-terminating? Because the denominator is not only the factor of 2 and 5. It is a factor of 3 and 7, right? Okay, and yeah, they are in the co-prime form, right? अब इसमें एक बात ध्यान रखना, इसमें कभी कभी क्या होता है, जैसे मान लो फॉर एग्जांपल आई एम आस्किंग अ क्वेश्चन 3 by 24. Up some people what they will do, they will say, oh sir, ये तो 3 into 2, this is 2 into 3 power 2 power 3 sir, right? Okay, 8 into 324. So that means it is to non-terminating, because in the denominator you can see it's a factor of 3. No, what I said is that they should be co-prime numbers, right? First of all, you have to cancel the 3. Okay, so now the remaining number is what? 1 by 8, and 1 by 8 has only the factor of 2, right? That means it is also terminating. It's 2 power 3 only, right? Got that? Okay, fine. Theorem number 2 is just the converse of theorem number first, guys. Okay, so देखो अभी मैंने आपको बोला कि if it is terminating, that means the denominator is have the factor of 2 and 5 only. Ulta is also true. Okay, that means अगर 2 और 5 का factor है, so it's gonna terminate. The same thing, right? It's not a big deal, right? Let's move forward. Okay, so decimal expansion of irrational numbers, as I said, guys, ki irrational numbers ki decimal expansion is gonna be always a non-terminating and non-repeating type. Okay, and for example, the decimal expansion is pi start with this, but not 500. ठीक है, we got it, right? है ना, हम पता ही है, not a big problem. अभी समझा दिया मैंने आपको already. So express 1 by 13 in decimal form. Let's start solving the problem. This is very simple question, guys. So you just divide it like that. ठीक है. So there is a decimal you will get. Then 10. अब देखो ये important, कभी ना अभी even you are in 10th standard, but some people make the mistake over here. First of all, there's a decimal. I have took a 0 from it, but it's not divisible now. 10 is still less than 13, right? So if I'll take one more 0, I have to keep a 0 over here as well, right? Now 7 times 91 will get a 9, right? I will take a 0. 6 times a 78, right? Then is a 12. 9 times a 117, right? There's a 3. 2 times a 26, right? And there's a 4. Then 3 times about 39, right? अब फिर से क्या आ गया 1. अब यहाँ पे you have to stop. Why? Because again you have been moved to the first starting point, right? अब again वो 100 आएगा, फिर again 100 आएगा, 91 आएगा, फिर सब कुछ it's gonna be the same, right? So now after this number it's going to repeat. So the next one would be what? 076923, 076923, 076923, like that. But sir, I am very sad right now. Why? Sir, do we need to write it like that? I mean, like, कब तक लिखेंगे? We have to write it, forever? No, you don't need to do that. Then how we gonna represent it? So you look, the repetition or the reoccurring thing we represent by a bar. Look, 076923. All the thing is repeating. So I'll put a bar on that. Now this bar is showing that 1 by 13 is 1 by 13 is 0.076923 in the recurring thing, the recurring order. That's my answer, right? Got that? Let's move forward. Okay. So yeah, chalo. Let's solve some problems now. So guys, can you just quickly solve this one? Represent in decimal forms. I'll not like take a lot of questions from this. This is quite easy for you guys. Okay, so 1 by 18, 3 by 90, and 2 by 7. Quickly solve these three questions. I'm giving you 4 minutes. No, 2 minutes. 2 minutes is sufficient for this. Okay, give it a try quickly. Any idea? Got it now? देखो whatever let me explain to you. 18. First of all, first question. You'll keep a decimal. It would be a 0. Okay. Again a 0. So you know it's like even if not solving it, you know one thing, guys. This is gonna be all of them are actually a recurring kind of things. Okay. Non-terminating and recurring. Fine. Okay. 5 times a 90. अरे sorry क्या बोल रहा हूँ मैं sorry 90 you'll get a 10 right you'll again get a 0 5 times a 90 again a 10 again a 0 again a 90 right so it's gonna be 0.05 bar अब देखो ये important है I am putting the bar only on 5 right now because the 5 is the only thing that is repeating 0 is not repeating na it's not 0.050505 no it's like 0.05555555 like that okay keep that in your mind okay this is like 1 by 30 only so you can solve it like that 30 so 1 I mean like a 0.0000 एक जीरो लिया डिविजिबल नहीं हुआ तो एक और जीरो लिया so I put a 0 over here 30 3s are 90 and then again a 3 then you take a 0 wait oh 1 sorry it's my mistake sorry okay again take a 0 guys but not divisible अब देखो यहाँ पे एक डिफरेंस आ गया फिर 90 then again a 10 you will take a 0 wait oh wait it's my mistake no गलत कर दिया मैं यहाँ पे वो sorry actually क्या होना था just a second guys एक second so now let's change the color as well रेड थोड़ा अच्छा नहीं लग रहा है ना काफी लोगों को देखिए 31 ओके सो 0.0 लिया नहीं हुआ तो एक बार 0 लगाया and it would be 30 right now 30 3s are 90 there will be a 10 but now it's divisible na 100 right 30 is a 90 then again a 10 then 100 okay so it's like the same like we got the earlier one 1 by 30 is what it is 0.03 bar is only on 3 right 7 and then 2 so then there's a bar there's 0 sorry there's 0 7 2s are 14 6 will remain okay 7 8s are 56 4 will remain 7 5s are 35 5 will remain 7 7s are 49 1 will remain okay 7 1s are 7 3 will remain 7 4s are 28 oh my god 2 will remain aha yep we got the pattern now because again it would be 20 and then 14 and then 60 56 the same thing right so that number is gonna be it's going to be 0.285714 and a bar got it okay that's it now clear सबको कोई doubt understood easy understood okay let's move forward guys so okay अभी तो बहुत कुछ करना बाकी है so अभी तो we have just learned that you know how to represent it from a decimal to sorry fraction to decimal form right now we are going to learn from decimal to fraction okay decimal to fraction अब now इसमें क्या है ना कि you need to understand the method fine for example let's say you have a number question है आपका represent 0.12 bar in decimal form. There's a bar on 1 and 2 both, right? So how are you gonna solve it? Look at first of all, you'll assume the number as x, that is 0.12. Bar hai to 1 2 1 2 1 2 you can write. Okay. Now look, please pay attention on what I'm saying. First step would be that you know you will see that after how many like after decimal, how many digits are there which are in the repetition. 2 digits are in repetition. If 1 digit is in repetition, you'll multiply it by 10. If 2 are in the repetition, you'll multiply it by 100. If 3 are in this, you'll multiply it by 1000 and so on, right? So here 2 digits are in repetition, I multiplied it by 100. So this equation only I multiplied by 100. So if I multiply x by 100, what I'll get? 100 times of x. Okay. And then if I multiply this by 100, what I'll get? I'll get 12.2121212 like that, right? Now it's like first wale ko you will just write it over here ऐसा जरूरी नहीं है you have to write it over here, just that it would become more easier for you, simpler for you to solve, that's why. Up now it is an important step, so please pay attention. Okay, देखो, it's 1 to 1 to 1 to 1 to. So after the decimal, like even you talk about the 100x or you talk about the x, after decimal there are infinite times 1 to 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 is like infinite times, right? So if we subtract these two, if subtract the first one and the second one, these two, what you will get? You will get, like if I talk about the right hand side rather, decimal ke baad to you have the same thing, na? That is get cancelled out. So 12 minus 0 would be what? 12. और यहाँ पे क्या मिलेगा? 100x minus x, 99 times of x. Okay. So what is your x? It would be 12 by 99. And that you can solve further. Yeah, you can cancel by 3. So 3 fours are 12. 4 by 33 is the correct answer. So what is the process over here? The process के अंदर भी एक important point ये था कि even by you first of all by which number you have to multiply. You have to multiply the number of digits that has been in the repetition after decimal. Okay, and after it it's simple, right? अब इसमें एक क्वेश्चन और बन सकता है, ऐसे फॉर एग्जांपल थोड़ा सा मैं आपको चेंज कर दिखाता हूँ क्वेश्चन को. लेट्स से आपको रिप्रेजेंट करना है 1.123 बार. नाउ द बार इज ऑन 2 3. द बार इज ऑन 2 3. इसमें ना एक बहुत इंपॉर्टेंट स्टेप है गाइस. लेट मी टेल यू द कॉन्सेप्ट बिहाइंड दैट. कॉन्सेप्ट क्या होता है? द पॉइंट एट विच यू सबट्रैक्ट द टू नंबर्स, द पॉइंट एट विच यू सबट्रैक्ट द टू नंबर्स आफ्टर डेसिमल they should be same. After decimal they should have the same thing in the repetition. Okay, then only you have to subtract it. Fine. How are we going to use this statement? Look at this question now. You have x equals to 1.1232323, right? First of all you are saying okay sir ठीक है, इसके अंदर दो repeat हो रहे हैं, 232323, right? So I'll multiply it by 100. No, first of all you will multiply it by 10. Why? I'll tell you the reason behind that. Because अभी ये क्वेश्चन उस फॉर्म में है, इन दिस फॉर्म we actually require it. We have to be you have to deal with this question in this form only. Why? Because now after decimal two are in repetition. Earlier what happened, but here what happened? Here one was not in repetition, other two was in repetition. That was not in the form in which we can solve the problem, we can tackle the problem. First of all what we did, we multiplied it by 10. Now it's in the form. Now we'll use the same concept that we have been using. What is the concept? How many digits are repetition? There are two, 3. We'll multiply it by 100, right? So if I multiply 10 by 100, what I'll get? 1000x. Here I get 1123.232323 and so on, right? Then I'm going to write the other one over here and then I'm going to subtract it. So it would be 11.232323. Subtract करोगे तो क्या आएगा? 990x equals to 1112, right? Okay, because after decimal they are the same thing, they'll get cancelled out. Fine. So your x would be equals to 1112 by 990. Okay, you can cancel it by 2 definitely. It would become 4 से कर लो ना सीधा. 4 से करो तो कितना आएगा? 4 2 जा 8 बचा एक. वेट 4 से ये नहीं होगा, लेकिन सॉरी 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 445 ना, 4 से नहीं होगा, 2 से हो जाएगा. And 2 से if you do this one now it will become 550. So 556, right? So answer is 556 by 445. Got it? ये concept है बस, that's simple. Okay, these are the two kind of question that I have been explained you, right? So अभी एक मिनट है, practice question बाद में देखते हैं, पहले एक सेकंड रुकिए आप लोग. Let me insert a slide over here and then let's solve a few more problem based on the same thing. Okay, just a second. Yeah, so guys, convert into which form? Fractional form, right? Fractional form. Let's start with the first question, that is 1.23 bar. Bar is only on 3. Then you have 0.123 whole bar, and the third one is 1.156 bar is on 5 6. Okay, there are 3 questions you have to solve. Give it a try. The bar is on 1 2 3. Okay, over here. Give it a try, please. I'll just back in a minute, guys. Okay, just give it a try. Okay, so I'm back and let's discuss this one. Okay, देखो first one discuss करते हैं पहले. First of all, you have been assuming is as x equals to 1.233333. As I told you, first of all, we need to multiply it by any number. We need to just do one thing, that after decimal, whatever is there, it should be in the repetition, right? So now it would become 12.333333, right? It is in the order repeater now. One digit is repeating. Multiplied it by 10. 10. You get 100x equals to 123.33333. We'll write it over here. It would become 10x equals to 12.33333. कैंसिल करोगे तो आएगा 90x equals to 111, right? Yeah, no? 231. Okay. So x would be equals to 111 by 90, and that can be written as what? 37 by 30. So the answer is 37 by 30. Got it? Okay. Let's move forward. Second one, 0.123. Ab ye, this is quite simple. Because this could be, this is like directly solvable. That's the only difference, right? इसके अंदर after a decimal there are 3 in the repetition, so multiply it by 1000 x equals to 123.123 and so on. And what was x? It was 0.123123 and so on. After decimal there's only one, so 999 x equals to 123, x equals to 123 by 999, and that would be 41 by 333. That's it. Got it? Last one, x equals to 1.156 bar. So 5656 again देखो, after decimal there are 2 in the repetition, but decimal के बाद there is one that is not in the repetition. First of all, let's take that before decimal, right? So multiply करोगे by 10 से, you will get 11.56565. Now the question is in our format, in which we want it to be. Yeah, it's in there. So now we'll multiply it by how many? What number? Like there are 2 in the repetition, we'll multiply it by 100. So 10 into 100 is gonna be 1000. 1000 x equals to 1156.5656 and so on. And what is your 10x? It is 11.565. So if you're gonna subtract it, guys, you get 990x equals to 1145, right? So x is equals to 1145 by 990. It is divisible by 5, both of them. So you'll get 229, right? Okay, here you get okay, sorry, 5 से कर रहे हो ना, 5 1 जा 5, right? I think it's 198 only. Okay, fine, that's your answer. Got it? Simple hai? Chalo. So guys, now this is homework questions. Prove that root 2 is irrational, determining if 11 by 25 is terminating or non-terminating, and convert the following into a rational form, right? So quickly let's do that, those questions. Okay, so ये तो हमने same किया है. This one is your homework. Okay, this one is that 11 by 25 is a terminating or a non-terminating number. So definitely in the denominator, it's 5 into 5, right? And if it is 2 and 5 only in the denominator, it terminates, right? So yeah, it is going to terminates, right? Terminates. And convert that into a rational form. It's simple question for us. X equals to 0.343434. First of all, you multiplied it by 100 directly, okay? Because there are 2 digits which are in the repetition after the decimal. Okay, everyone? Then you go right. The first one को वापस लिखते हैं. सिर्फ उसका reason ये होता है कि that would become easier for us to subtract, right? So 99x equal to 34. Your x equals to 34 by 99. That's it. We got the answer. Simple. Okay. Okay. Okay then, guys, that's it on today's session. Now for the homework, you can definitely solve your NCERT book and the module as well. Whatever doubt you get, you just need to put the doubts on the PDF. Definitely I'll be answering whatever doubt you'll be having, guys. Okay, and okay. Baki like we'll like almost finish the chapter. Abhi next class and we'll discuss some higher order questions and some difficult things as well. Okay, so take care then. Bye bye. Take care, everyone. See you in the next class. Bye bye, guys. Bye.